Okay, I've got a point A and a point B out here. And then we've got point C that has a missing coordinate. This is point A, this is point C. We've got point B with a missing coordinate. And we're asked, what should that missing coordinate be to make, this is A, B, oops, A, B plus BC to be at a minimum. Right, so the smallest value possible for AB plus BC. Well, first, let's think about where this point B could be. So we know it has a y coordinate of 3, but we don't know its x coordinate, which means that it could be, for example, 1, 3, or 2, 3, or negative 2, 3, or negative 4, 3. In fact, it could be anything along this line. Let's find it here. It could be anything along this line, y equals 3. Right there, y equals 3. Anything on that line. And, if I want to think about it, if we want AB plus BC to be at a minimum, right? We don't want, say, B to be way over here, right? Because that looks like way out of the way. It could be a lot shorter than that. We don't want it to be way over here and up, right? Because AB means the distance from A to B. BC means the distance from B to C. And so we're talking about the total path from A to B to C. We want it to be as short as possible. So we clearly don't want B to be way over here or way over here. In fact, if you think about it, where we want B to be is directly, because the shortest distance from A to C is just a straight line. And so we want B to be on that straight line, right? Right on the way to C, so we don't have to go out of the way at all. So let's connect A and C with a line. Now let's pick red. So let's see. So we want C to be right here. Or B, I'm sorry, I keep saying C. I want C to be right there. B to be right there. So I want B to be right here. So now, the distance from A to B plus the distance from B up to C will be as short as possible. Can't get any shorter than that, straight line. The only problem is I still don't really know quite where that is, right? I know the y coordinate is 3, but I don't know what the x coordinate is. It's not on a grid line, so I can't tell. So we've got to figure it out somehow. There's a couple different things that we could do. One is we could write the equation of the line that passes through these 2 points, and then we can plug in y equals 3. Right, so let's see what happens there. This equation is probably going to be best written in point-slope form. So it would be y equals mx minus h plus k, where m is the slope of the line, and h and k is just some point on the line. And the slope of this line, let's figure out what that is, because we're going to need that anyway. Let's see. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7. So the slope of this line is 13 over 7. That's not going to be nice. So y equals 13 over 7. X minus, let's pick a point down here. We'll pick, let's pick this point. X minus 5 plus 9. Okay, I don't need to get my fancy fraction calculator out. Okay, so let's see. Y equals 13/7 x minus 65/7. That's okay. 13/7 times negative 5 plus 9. So what is 9 minus 65/7? That's negative 2/7. So that's 13/7 x minus 2/7. And oh, I plug in my value for y over here. which is 3. So 3 equals 13/7 x minus 2/7. I'm going to add 2/7 to each side. So 3 plus 2/7. But I kind of want that in a improper fraction form. It's 23/7 equals 13/7 x. I need to divide by 13/7 on each side. Divide by 13/7, and I get 23/13. 23/13. Ugh, that's an ugly number. So the point here is 23/13, comma 3. All right, so that's one method. The one method was that we set up the equation of our line using the slope at a point-slope equation, and then we just plugged in a value for y equals 3, and we solved for x, and we got x is this ugly number, 23/13. So let's try another method. Right? The other method would be to say, well, how far is it how far are we between the y coordinates? So we're from -4 to 9, and we're at 3. Right, so that's like asking, if we travel from A to B, what portion of our up-down journey have we taken, right? So to go from A to B is a total of 13 units up. I don't mean B again, I keep saying it wrong. From A to C is 13 units up. And by the time we reach B, we've gone up to the point y equals 3. What portion of our journey have we taken already? So we've taken from -4 up to 3. So that's 3 minus -4 out of 13. Hold on a second. Before I continue, I want to preface this probably needs a little more explanation. The slope of this line is 13/7, right? 13/7. And the slope of the line can be calculated with any 2 points, and you'll always get 13/7. So I calculate it from A to B, I get 13/7, up 13/7. But I could also calculate it from A to B. I did it again. I said A to B. I meant A to C. A to C, 13/7. But I could also calculate the slope from A to B, right? So I could say that if I want to go, let's see, let me try to write this out. I'm going to run out of space here. Our slope formula is y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So this is our change in y divided by our change in x. And we know this is going to be 13/7. Right? And we know our change in y from A up to B is end minus start equals change. So 3 minus -4. So I could say 3 minus -4 over x sub 1 minus x sub 2 equals 13/7. And I do know one of my x-coordinates. One of my x-coordinates is -2. And I want to make sure I keep them lined up correctly. So since I went 3 minus -4, I need to go unknown x minus -2. So I have 3 minus -4 equals x sub 1 minus -2. And all that should equal 13/7. So let's do a little simplifying here. Let's see, 3 minus -4 is 7, and this should be x sub 1 plus 2 equals 13/7. I'll do a little cross multiplying here. Get 13x plus 2 equals 49. X plus 2 equals 49 over 13, and x equals 49 over 13 minus 2. 49 ABC 13 minus 2, which I'm going to have to 23/13. 23/13. Okay. So again, we have the same answer. So again, two methods. One, set up our equation of the line using point slope form, where so m is the slope, h and k is the point. Remember, it's x minus h, and then you put the plus k at the end. And we just plug in our slope, plug in one of our 2 points. It doesn't matter which one. I could have picked the other one, didn't matter. Substitute the value we know for y, which is 3, and then we just solve for x, 23/13. On the other hand, we could use our slope formula, because we know that slope will be the same no matter what 2 points we pick. So I can pick a as one of our points. I pick that as the second point, and I plugged in -4 and -2. Right? And I knew my y-coordinate for the unknown point, and all I had to do was solve the equation for the unknown x-coordinate, right, using the slope formula. So two methods, whichever method you prefer, doesn't really matter. There are some other methods that you come up with. I mean, there are lots of different ways to solve it. This is just two.